Okay, so let's talk about some chemical properties of alkanes in today's class. That is very important about the chemical properties of alkane because it is a very much, you can say that, consistent part of exams, right? So let's talk about chemical properties. Chemical properties. So वैसे we just have two chemical properties in our syllabus. The one is combustion and the second one is substitution. We just have two chemical properties. The one is combustion and the second one is substitution reaction, which is known as actually in A levels free radical substitution reaction. If you remember your O levels, you name that as a substitution reaction, and now we are just going to learn this further. So it can be named as free radical substitution reaction, right? So these are the two chemical properties that you need to discuss in your syllabus. But over here, I'm adding one more chemical property, which is actually not defined as a chemical property in your syllabus, but defined as a syllabus, or right, defined as a process in your syllabus, right? ये cracking जो है आपके syllabus में process के तौर पे define किया गया है. It is not defined as the chemical property of alkane. So, but I just want कि मैं इसको यहीं पढ़ा दूं साथ साथ अलग से ना पढ़ाना पड़े, इसलिए I'm just considering this as a chemical property of alkane and will describe you over here, right बच्चों? So ये तीन केमिकल प्रॉपर्टीज हैं जो कि अल्केन्स की आपने पढ़नी है, राइट, ताकि आप हर क्वेश्चन अल्केन से रिलेटेड कर सकें. ये तीन केमिकल प्रॉपर्टीज बहुत ज्यादा इंपॉर्टेंट हो जाती हैं. So let's start with the first one, which is actually the combustion, right? Combustion. Right now we are talking about combustion of alkanes, right? So this is combustion of alkane because we are talking about the chemical properties of alkanes. Right, but so what is combustion? Combustion is anything which is going to be burned in the presence of excess oxygen, right? When something going to burn in the presence of excess oxygen, it is known as combustion, right? So right now, for example, we are talking about alkanes right now. So definitely we are going to write the chemical equation of the combustion of the first member of alkane family. So जब पहले member को हम combust करेंगे, तो it is methane. And definitely the combustion is burning in the presence of oxygen, so the reaction is always with oxygen, right? तो यहाँ पर combustion में हमेशा reaction oxygen के साथ होना है, तो oxygen के साथ reaction हो गया. Now you need to keep remember one thing, which is very important to write the products of the combustion equations, right? All the time, you need to remember this word. What I'm saying that the elements present in a compound, when you are going to combust the substance or any compound, when you combust that compound or any substance, the element present over there in that compound or substance are going to form products with oxygen, right? So we have carbon and hydrogen over there as an element over there as an element in this compound. So ये जो मीथेन है, ये compound है, इसको आप combust कर रहे हो. इसके अंदर जो elements हैं, इसके अंदर जो एलिमेंट्स हैं वो ऑक्सीजन के साथ क्या बनाएंगे बच्चों? कंपाउंड्स बनाएंगे. तो कौन कौन से एलिमेंट्स हैं इसके अंदर? अगर आप देखते हैं तो इसके अंदर एक कार्बन है और एक आपके पास क्या है? आपके पास हाइड्रोजन है. तो ये दोनों ऑक्सीजन के साथ कंपाउंड्स बनाएंगे, ठीक है ना? अब आप मुझे बताएं, कार्बन को ऑक्सीजन के साथ सबसे स्टेबल कंपाउंड कौन सा है भाई? कार्बन डाइऑक्साइड, जिसके बारे में आपने बहुत सुना होगा. और हाइड्रोजन को ऑक्सीजन के साथ स्टेबल कंपाउंड कौन सा है? वाटर. सो दिस will be the product of this reaction. Keep remember this. What I'm trying to say, I'm saying that, for example, if you are burning any substance, for suppose you are burning sulfur. So over here, this is element, right? So when you combust sulfur, so it will form the compound with oxygen. If you combust nitrogen, so it will form what? The compound with oxygen, right? If you combust carbon, so it will form compounds with oxygen, right? For example, if you combust magnesium, so it will form compound with oxygen, right? Same as it is if you are burning substances that have more than one element, so definitely they are going to produce more than one compound of oxygen. So this is one of the proof of this. When you combust a substance having two different elements over there, both the elements form different products with oxygen, right? So you need to keep remember this for writing the chemical equations of combustion, right? So compound, when you combusted, right? Compound combusted, right? Always form binary products of oxygen. binary products of oxygen by the elements present in it. अगर आप ये बात याद रखते हैं तो इस बात से आप क्या कर सकते हैं, ये याद रख सकते हैं कि कोई भी इक्वेशन आप बना सकते हैं बाय दिस. राइट नाउ यू कैन सी दिस, वी आर टॉकिंग अबाउट मीथेन. तो मीथेन को हमने कंबस्ट किया तो इसके अंदर कार्बन और हाइड्रोजन था, तो भाई हमारे पास कार्बन डाइऑक्साइड और वाटर बन गया. राइट, तो अब पूरा का पूरा आपके पास हाइड्रोकार्बन, जितने भी हाइड्रोकार्बन, अल्केन हो, अल्कीन हो, अल्काइन हो, साइक्लोअल्केन हो, साइक्लोअल्कीन हो, व्हाटएवर द हाइड्रोकार्बन यू हैव, जब वो कंबस्ट होगा, सो वी नो दैट हाइड्रोकार्बन में तो कार्बन और हाइड्रोजन ही होता है. जब भी वो कंबस्ट होंगे वो हमेशा हमेशा कार्बन डाइऑक्साइड और वाटर ही बनाएंगे. इज दैट क्लियर बच्चों?
यस सर.
बस बैलेंसिंग का डिफरेंस आएगा, ठीक है ना. अब आपको बैलेंस करते वक्त आपको याद रखना है, पहले कार्बन फिर हाइड्रोजन और फिर ऑक्सीजन बैलेंस करना है आपने. पहले कार्बन फिर हाइड्रोजन फिर ऑक्सीजन. You can see this, we have one carbon over here, one carbon over here. It is already balanced. Now we have 4 hydrogens over here, so we can write 2 over here to balance the hydrogens. Hydrogen balance हो गए. अब बचे oxygen, so we have 2 oxygens and 2 oxygen, 4 oxygen, so we can write 2 over here for the balancing of oxygen. Is that right, बच्चों?
Yes sir.
So this is the case that you need to keep remember for the combustion, right? So if you talk about the second member of this family, which is C2H6, when you combust this in the presence of oxygen, it will form what? Again, carbon dioxide and water. And for the balancing, you can see there's 2 carbons, just write 2 over here, 6 hydrogens, just write 3 over here. And if you talk about oxygen, so it is 3 1s are 3, 2 2s are 4. So total oxygen आपके पास कितनी होगी बच्चों? 7 oxygens हो गई. So you can write 7 over 2 over here for the balancing. ठीक है बच्चों? Is that clear? Is that clear, every one of you?
Yes.
चलें, अब मुझे जल्दी से combustion लिख के दिखाएं. Write down the balanced chemical equation for the combustion of propane, butane, pentane, and hexane. Just do it quick. I want 6 balanced chemical equations from your side. You need to write the chemical combustion equations of these 4 compounds. Just do it quick and send me the picture so I can check. For example, you are writing equation of propane with like oxygen, right? You're combusting propane in the presence of oxygen. So क्या बनता है आपके पास? Carbon dioxide and water, right? So how many carbons you have right now? 3. So you are just going to write 3 with carbon dioxide, and the number of hydrogen are going to be half over there, right? And then you balance oxygen accordingly. So actually in our syllabus we have general equation for this as well, right? We have general equation for this as well in our syllabus, okay? इसको शो करती है, इसका जर्नल पैटर्न शो करती है. So you can say that general equation of combustion, right? General equation of combustion is saying that, for example, whatever the hydrocarbon you have, the number of carbons in the hydrocarbons are always equal to the number of carbon dioxide produced, right? And the number of hydrogens are always double the number of water molecules produced. It is like this. And for the balancing of oxygen, you need to keep remember this one, x plus y over 4 oxygen, right? So you just look at over there this general equation. This will give you perfect answers, right? So for suppose according to this, if I use C5H12, so just look at over here, x is 5 and 12 is y actually. So right, this is oxygen and I have 5 carbon dioxide and 12 by 2, 6 water molecules, and this is 4 1s are 4, 4 3s are 12, and it will be 8 oxygen molecules, right bacho? So you can even balance equation by this way, right everyone?
Yes sir.
Yes.
Yeah.
But this equation is many more than the balancing. इसके पास बैलेंसिंग से ज्यादा इंपॉर्टेंट चीजें भी हैं जो कि हमें डिस्कस करनी है. इसके अंदर कुछ क्वेश्चंस आपके पास कंबशन से रिलेटेड मोल से कनेक्टेड आते हैं पेपर में, जो कि आपको सॉल्व करने होते हैं. हम वो करेंगे, ठीक है, इसको यूज करते हुए. लेट्स सी, for suppose I have one of the question over here. मोल से कनेक्टेड क्वेश्चन है ये. For suppose बच्चों we have a question that 10 centimeter cube of propane is completely combust. 10 centimeter cube of propane is completely combust in the presence of excess oxygen, in the presence of excess oxygen, right? And excess oxygen आपके पास कितनी है बच्चों? We have 100 centimeter cube excess oxygen over there, right? So this is what the question saying to you. अब देखें, आपने सीखी combustion की equation है, सवाल में एग्जामिनर आपसे ये पूछ रहा है. So this is the thing you need to understand ना कि एग्जामिनर आपको सिखाता क्या है और आपसे पूछता क्या है. वो आपको मोल्स अलग से सिखा रहा है, वो आपको combustion equations अलग से सिखा रहा है, और उसके बाद सवाल वो आपसे पूछ रहा है combine. So you need to be very vigilant और वो आपको कैसे सॉल्व करने हैं. ठीक है ना. क्वेश्चन इज दिस, they are asking calculate the following things. Calculate what volume of carbon dioxide produced. They are asking for the volume of carbon dioxide produced. They are asking for the volume of oxygen used. They are asking for the volume of oxygen remain. They are asking for the total volume at the end. Total volume at the end of reaction. So this is what we need to find out over here. But so how can we solve this question? For this, first of all, you need to write a complete balance equation. So let's see what is the complete balance equation. The balance equation is saying when you have 3,3H8 propane is going to be combust in the presence of oxygen, it will form 3 carbon dioxide and 4 water molecules, and this is 5 oxygens. Right, bacho? Right, bacho?
Yes, sir.
Then this is a gaseous state. This is gaseous state. This is gaseous state, and this is liquid at room temperature and pressure. अगर आप room temperature and pressure की बात करो तो this is liquid, right? So you need to remember one important point. Very important point. The point is saying that the mole ratio is always equal to the volume ratio. The mole ratio is always equal to the volume ratio for gases. It is for gases at room temperature and pressure. ठीक है, आपने याद रखना है कि रूम टेम्परेचर और प्रेशर पे गैसेस के लिए मोल रेशियो और वॉल्यूम रेशियो सेम होता है. और ये क्यों सेम होता है? देखें, अगर आप बात करें 1 मोल की तो 1 मोल इज ऑलवेज इक्वल टू 24 डेसीमीटर क्यूब. अगर आपके पास 2 मोल्स होंगे so it will be 48 decimeter cube, है ना? The relation is always same. 24 1 to 24, 24 2 to 48. So the relation is same, right? So mole relation and the volume relation for gases are always same because any gas at room temperature and pressure and having the same volume as compared to the other gases. So carbon dioxide हो, oxygen हो, कोई सी भी गैस हो, सबका volume same होता है same moles के अंदर ना. तो mole ratio को और volume ratio को आप same consider कर सकते हो. तो for suppose अगर हम कोई और कैलकुलेशन कर रहे होते जिसके अंदर गैसेस ना होती, यू कैन इवन कंसीडर दिस कि ये 1 मोल है, ठीक है ना, ये 5 मोल्स हैं, ये 3 मोल्स हैं. इक्वेशन में जो चीज गिवन है आप उसको मोल कंसीडर करते हो, है ना. कैलकुलेशन के लिए आसानी के लिए आप इसको जो है मोल कंसीडर करते हो, ठीक है ना. लेकिन अगर गैसेस हो तो आप इसको वॉल्यूम भी कंसीडर कर सकते हो. दिस इज द थिंग टू अंडरस्टैंड. जो मैं आपको बताना चाह रहा हूँ वो ये है कि अगर सारी गैसेस हैं तो मोल्स की जगह आप इसको वॉल्यूम कंसीडर करो तो कोई मसला नहीं होगा, आसानी से सॉल्व हो जाएगा. So you can even consider this 1 centimeter cube, that's fine. Or you can write this 5 centimeter cube, that's fine. You can write this 3 centimeter cube, that's fine. ठीक है ना. अगर इक्वेशन के अंदर जो स्टेशोमेट्रिक नंबर्स हैं उनको आप वॉल्यूम के लिए यूज कर रहे हो, आप कर सकते हो अगर गैसेस हैं. So you can say that 1 centimeter cube requires 5 centimeter cube of oxygen and produce 3 centimeter cube of carbon dioxide. But right now we have 10 centimeter cube. We have 10 centimeter cube, so we need to work according to the 10 centimeter cube. So अगर मैं इसको 10 centimeter cube के लिए बनाऊं, so I need to convert 1 centimeter cube into 10 centimeter cube by multiplying with 10. जब इसको 10 से मल्टीप्लाई करा रहा हूं तो इसको भी 10 से मल्टीप्लाई कराना पड़ेगा और इसको भी 10 से मल्टीप्लाई कराना पड़ेगा. So you can see this, if you have 10 centimeter cube of propane gas, so it requires 50 centimeter cube of oxygen for complete reaction, and it also produces 30 centimeter cube of carbon dioxide after the complete reaction. ठीक है. So you can say that, okay sir, कार्बन डाइऑक्साइड जो प्रोड्यूस हुई है, वॉल्यूम ऑफ कार्बन डाइऑक्साइड जो आपके पास प्रोड्यूस हुआ है, इट इज एक्चुअली 30 सेंटीमीटर क्यूब. It is actually 30 centimeter cube, and the volume of oxygen used, volume of oxygen जो used हुआ है, it is actually 50 centimeter cube. And we have excess oxygen in the start. So बचा कितना oxygen, remain कितना बचा हमारे पास? We were having in the start 100 centimeter cube. हमने 50 used up कर लिया, तो 50 बच गया. ठीक है. And at the end of reaction, what is the total volume if you want to know? So total volume क्या होगा बच्चों? 10 सेंटीमीटर क्यूब गैस थी, वो तो यूज्ड हो गई, तो वो तो बची नहीं. बची क्या? 50 सेंटीमीटर क्यूब ऑक्सीजन, और बनी क्या? 30 सेंटीमीटर क्यूब कार्बन डाइऑक्साइड. So the total volume at the end of reaction is 80 centimeter cube. Is that right, every one of you?
सर 80 समझ में आई, आपने 10 से मल्टीप्लाई क्यों किया?
किससे मल्टीप्लाई किया?
10 से.
10 से मैंने मल्टीप्लाई इसलिए किया है क्योंकि हमने यूनिटरी मेथड में लिखी थी ना पूरी इक्वेशन. हमने तो जो स्टेशियोमेट्रिक नंबर इक्वेशन में था उससे लिख दिया था कि 1 सेंटीमीटर क्यूब ऑफ प्रोपेन रिक्वायर्स 5 सेंटीमीटर क्यूब ऑफ ऑक्सीजन एंड 3 सेंटीमीटर क्यूब कार्बन डाइऑक्साइड वुड बी प्रोड्यूस. इट इज फॉर 1 सेंटीमीटर क्यूब. बट अगर आप क्वेश्चन में देखें तो यू हैव 10 सेंटीमीटर क्यूब ऑफ प्रोपेन. जब आपके पास यूनिटरी मेथड में सब कुछ है मौजूद कि एक होगी तो 3 ऑक्सीजन चाहिए होगी, 5 कार्बन डाइऑक्साइड बनेगा, तो आप उसको 10 में कन्वर्ट करने के लिए सबको 10 से मल्टीप्लाई करा दो. तो अगर एक है तो 3 सेंटीमीटर क्यूब ऑक्सीजन चाहिए होगी, 10 है तो 30 चाहिए होगी. एक से अगर 3 सेंटीमीटर क्यूब या 5 सेंटीमीटर क्यूब कार्बन डाइऑक्साइड बन रही है तो 10 से कितने बनेगी? 50 बनेगी. सो वी कैन कन्वर्ट दिस बाय मल्टीप्लिकेशन, राइट?
यस.
यस. एनीवन एल्स? एनी प्रॉब्लम बच्चों? Yes, every one of you. Is that clear? Should I give you one more question for this? चले, इसका एक सवाल करते हैं. सवाल क्या होगा इसका? For suppose I am changing the volume of the gas over here. I am giving you 15 centimeter cube. I am changing the gas as well. Over here we have propane. I am giving you pentane. When pentane is completely combust, it produces or whatever we need to find out. और यहाँ oxygen excess में 200 मैं आपको दे रहा हूँ. So I am changing these 3 values. Just find out these 4 things again with these information. Just do it quick and send me the answer so I can check कि आपके समझ में आया. चलें. अब देखिए बच्चों, क्वेश्चन आपके पास मौजूद है. आपके पास है 10 सेंटीमीटर क्यूब अननोन हाइड्रोकार्बन्स बर्न इन द प्रेजेंस ऑफ एक्सेस ऑक्सीजन. दे आर सेइंग एक्सेस ऑक्सीजन, और एक्सेस ऑक्सीजन आपके पास 70 सेंटीमीटर क्यूब है. And after the complete reaction, 20 centimeter cube carbon dioxide produced and 40 oxygen left. यानी कि 30 used हुई. ठीक है ना? So we can write the general equation over here. Just look at over here. If we move towards the general equation, so the general equation is what? The general equation is CXHY. We need to write the general equation over here. This is CXHY. We don't know the hydrocarbon, that is why we are writing that it is unknown, right? And we know that the oxygen is always X plus Y over 4 oxygen used for the combustion of any hydrocarbon, and it always produces X carbon dioxide and Y over 2 water molecules, right? So we know that in the question they gave us 10 centimeter cube of unknown hydrocarbon. They told us that we use initially excess oxygen 70 centimeter cube, but not all the oxygen is used, so it is 40 remain. So actually used is 30. And they told us that 20 centimeter cube carbon dioxide is produced, right? So we need to take a simplest ratio of these first. We know that they all can be divided by 10 to be like this. It will be 1 centimeter cube, 3 centimeter cube, and 2 centimeter cube, right? Now these are the numbers. So you can say that you can convert easily them into moles. So it will be like this, because we know that the mole ratio and the volume ratio are same for gases. So it is saying that this value is 3 and this value is 2. So that means you have the value of X is equals to 2, right? And you have X plus Y over 4 is equals to 3. And we also know the value of X as well. So we can put this over here to get the answer, right? So it will be 2 over there. It will be subtracted, right? It will be 3 minus 2. It will be 1. And then 4 ones are 4. So the value of y is equals to 4. So it is giving you what? CXHY, and this is C2H4. Is that right, bacho? Is that right, bacho?
Yes, sir.
इस तरह से आपने आइडेंटिफाई करना है हाइड्रोकार्बन्स. If something is unknown, you can find out in this way. Is that clear to every one of you? Just take a picture of this, everyone.
Yes.
Then you need to solve the second one. This is your task now. They are saying that you have a hydrocarbon, right? और वो जो hydrocarbon है वो आपके पास unknown है, right? So this is an unknown hydrocarbon with 10 centimeter cube volume, right? We are burning unknown hydrocarbon in the presence of excess oxygen, right? This is excess oxygen, right? And it is producing carbon dioxide and water as well, right? We are not concerned with water because it is liquid. We always talk about gases at room temperature and pressure because the mole ratio and volume ratio of gases are same. So what is the excess amount of oxygen that we used? You can see over here that we use 100 centimeter cube of oxygen. Initially, we have 100 centimeter cube of oxygen, right? And they are saying that once the reaction has been completed, you have 95 centimeter cube of reaction mixture. मतलब वो बोला मिक्सचर जो आपके पास बचा है वो 95, ठीक है ना? उसके बाद आपने उस मिक्सचर को, ऐसे बात है, उस मिक्सचर में आपके पास रिमेनिंग ऑक्सीजन और कार्बन डाइऑक्साइड जो प्रोड्यूस हुई है वो होगी, है ना? वो कह रहा है 95 सेंटीमीटर क्यूब को आपने जो है ट्रीट कराया सोडियम हाइड्रोक्साइड के साथ टू रिमूव द कार्बन डाइऑक्साइड, तो वो जो 95 वॉल्यूम था वो 75 तक रह गया. इसका मतलब ये है कि 20 सेंटीमीटर क्यूब कार्बन डाइऑक्साइड बनी थी जो कि NaOH की ट्रीटमेंट के बाद रिमूव हो गई, ठीक है? तो जो बाकी 75 बचा वो क्या होगी? वो अनरिएक्टेड ऑक्सीजन होगी. तो मतलब रिएक्ट कितनी हुई ऑक्सीजन? यू कैन सी दैट 25 रिएक्ट हुई. तो ये आ गया आपके पास द प्रोसेस, और यू कैन से दैट द मेन कंटेंट. अब आप इसका सिंपलेस्ट रेशियो निकाल लें, डिवाइड बाय 10 कर इट विल बी लाइक दिस, राइट? तो x की वैल्यू आपके पास आ गई 2 एंड इसकी वैल्यू आ गई 2.5. So you can say that sir x is equals to 2, and if you talk about x plus y over 4 is 2.5. You can put the value of x over there, which is 2, and then it will be like this. Just send 2 over there, so it will be y over 4 is equals to 0.5. When you multiply 4 with 0.5, it will give you 2. So the unknown hydrocarbon is C2H2. Is that clear, bacho? Yes, everyone, is that clear to all of you?
Yes, sir.
This
Yes,
is
sir.
the way to solve this question. Acha, we have one more question. It is your homework, bacho. Just take a picture of this. You need to find out the number of carbon, hydrogen, and oxygen over there first, right? Whatever the molecular formula of this. This is actually skeletal formula. You need to convert this into molecular formula. Then you need to write the complete balanced chemical equation for the combustion of this. And then whatever the relation of carbon dioxide and water you have, you need to make that simplest, right? Just take a picture of this. This is your homework. This is one of the MCQ, or you can say that one of the theoretical part of the question as well for 1 or 2 marks. So you can take a picture of this. You need to complete this, right, bacho? Right? Yes, everyone.
Sir.
Is that